Right, so for moving on to the next lecture is about the derivative and rate of change. So once again, I'm going to go back to the idea of the velocity problem and the tangent problem. I'm going to go back to that to look at those two problems again, and from there we're going to talk about derivatives and rate of change. So first, slope of a secant line and average velocity. So consider the points. P, A, F of A, and Q, X, F of X. Then the slope of the secant line, PQ, or the average velocity between P and Q is, right, so the slope of the secant line and the average velocity, they use the same formula to calculate. So the slope of the secant line is equal to f of x minus f of a divided by x minus a. So this is also equal to average rate of change. If we write h equal to x minus a, or right, so x minus a is the distance between x and a, right? So on the graph, if you have on the real line, if you have this is a, this is x, the distance between a and x is h, right? So h is equal to x minus a. Or you can write x equal to a plus h. Then the slope is, or average velocity, or average rate of change is, right, you have two formula. You start with f of x minus f of a over x minus a. Now this can be written as f of a plus h minus f of a divided by h. And this formula is called the difference quotient. The slope of a tangent line and instantaneous velocity. Right, so the slope of a tangent line equal to the limit of f of x minus f of a over x minus a as x approaches a. Right. Without the limit, that is the difference quotient, that is the slope of the secant line. But when you apply a limit as x approaches a, you have a slope of the tangent line. And another formula is that limit of x as a limit of f of a plus h minus f of a over h as h approaches 0. So, right, this makes sense, right? Because h is equal to x minus a, right? So as x approaches a, h approaches 0. So as x approaches a, h approaches 0. So that's why you have In the second formula, h approaches 0. This formula can be used to calculate the slope of the tangent line to the curve y equal to f of x at the points a comma f of a. The instantaneous velocity after t equal to a, or the instantaneous rate of change after t equal to a. So for example, find an equation of a tangent line to the parabola y equal to x squared at the point 1, 1. But to find the equation of the tangent line, right, you need to slope in the point, or for any equation of the line for that matter. So you need to slope. In order to find the slope, you have m equal to the limits of f of x minus f of a, x over a as x approaches a. Right? So that's the slope of the tangent line. And f of x is x squared. A in this case equal to 1, right? A quick note here, given a equal to 1. So a is the value, this is a. So you have the limit of x squared minus f of 1, which is 1, over x minus 1 as x approaches 1. And so I say that a equal to 1 and f of a is also equal to 1. Right, if you use direct substitutions, you will have 0 over 0, which is the indeterminate form. What you can do is you factor the numerator into x minus 1 times x plus 1 divided by x minus 1. You cancel out the x minus 1 and you're left with limit as x approaches 1 of x plus 1, or this equal to 2. Right, the slope of the tangent line is equal to 2. So the equation of the line is the equations of the tangent line is y minus y0 equal to m minus x0 for x0, y0 equal to 1, 1. We have y minus 1 equal to 2 times x minus 1. Well, this is y equal to 2x minus 2 plus 1, or y equal to 2x minus 1 for the answer. So for this example, I have suppose that a ball is dropped from an upper deck of a tower 450 meters just above the ground. Right, so there's a few parts to these questions that I would like to give you. So the first part is, can you find the velocity? find the velocity of the ball after t equal to a seconds, right? So for a is any constant. When I say velocity, right? So I mentioned about this before. When I say velocity, it means instantaneous velocity. Right? It's the same meaning. So you use the formula we just briefly talked about. You can use limit as x go to a of f of x minus f of a divided by x minus a. So what is f of x in this case? We go back to the first lecture when we talk about you drop a ball from a certain height. There's a position function, and the position function is given. So f of x is equal to 4.9 t squared. Right. So this is the position function of the free fall object, and you can substitute into the limit of f of x minus f of a divided by x minus a. So the limit as x approaches a of 4.9 t squared minus a, so t is equal to a, so it's 4.9 times a squared, everything divided by t minus a. So it's not, so let me correct my notations here. This is t approaches a, t minus a, and this is of course f of t, sorry. If you use direct substitutions, you will find out that you're going to get 0 over 0, which is indeterminate form. For so you need to do some simplifications before you can make the substitutions. So you can see that you can simplify, you can factor the numerator. So limit as t go to a of 4.9 as the common factor times t squared minus a squared over t minus a. T squared minus a squared is the difference of two squared, so it's t minus a times t plus a. Divided by t minus a. All right. So they have the same factor on the numerator and the denominator, so you can make the cancellations. Therefore, you have limits as t go to a of 4.9 times t plus a. Now you let t go to a, you get 4.9 times a plus a, or this is 4.9 times 2a, or 9.8 times a, for a is time after you drop the ball. Right, so this is the instantaneous velocity. Okay, so that's part A. So part B, going to use the formula we just found for the instantaneous velocity. So for this, say that what is the velocity of the ball after t equal to 5 seconds? Right, very simple, right? We already derived the instantaneous velocity after t equal to a second, right? So just going to substitute a equal to 5 into the instantaneous velocity formula. So the velocity after 5 seconds is equal to 9.8 times 5, which should give me 49 meters per second. So part C, nice. So how fast is the ball traveling when it hits the ground? So you want to find velocity when it hit the ground, right? So you want to know when it hits the ground. First questions to ask is, when does the ball hit the ground? right? Because in order to find the velocity, you need the time, right? We have the formula for the velocity, but you need time to make the substitution. So when you need to know when the ball hit the ground, right? So that means you need to find time, find t equal to, right? So that's what we're looking for. From the position perspective, right? You start on top of the building, right? You drop the ball. So the position functions is 4.9 t squared. And when it hit the ground, it travel at the distance of 450 meter, correct? Right, so the ball travel 450 meter when it hit the ground. Right, so that's how you set up the problem in order to find the time it takes for the ball to travel that 450 meter length, right, or height. Right. So t squared is equal to 450 divided by 4.9. You're going to have plus and minus solutions here, but we're talking about time, so we're just going to choose the positive number. So this implies that t is equal to 9.58 seconds. So it took 9.58 seconds for the ball to travel 450 meters to hit the ground. And then, of course, you're going to calculate how fast the ball travels when it hit the ground. Right, you know the instantaneous velocity, right? Which is v of a equal to 9.8 times a. And a is the time it travel, right, at that given moment. And here, when it hit the ground, it it took 9.58 seconds. So you're going to substitute that into the formula for A. So 9.8 times 9.58. And for this calculation, this is approximately equal to 94 meter per second. All right, so this two example, the example of the equation of a tangent line and the instantaneous velocity will give you the idea that when you take the limit of the difference quotients, you can have something you can calculate the slope of a tangent line or the instantaneous velocity. And in general, this is called the derivative, right? So the formula we've been using to calculate the instantaneous velocity or tangent, the slope of a tangent line is called the derivative. All right, so which is the next topic, derivative. In this case, just going to give you a definitions. So the derivative of a function at a number a denoted as f prime of a is, right, so f prime of a is the derivative of the function at a given point a. It's equal to the limit of f of x minus f of a divided by x minus a as x approaches a, or limit as h approaches 0 of f of a plus h minus f of a divided by h, provided that the limit exists. For example, find the derivative of the functions f of x equal to x squared minus 8x plus 9 at the number a. So for this example, find the derivative of the function f of x equal to x squared minus 8x plus 9 at the number a. So for this, very simple, right? You're going to apply the formula we just have right here, right? So the limit of f of a plus h minus f of a divided by h, right? Given that f of x is equal to x squared minus ax plus 9, we're going to use the formula f prime of x, f prime of a is equal to the limit of f of a plus h minus f of a divided by h as h approaches 0. Right. So for this, I'm going to write out what is f of a. Right. Before I even start, substitute everything into the formula, just going to write down f of a. So f of a is, of course, a squared minus 8a plus 9. And what is f of a plus h? This is a plus h squared minus 8 times a plus h plus 9. Now let's substitute everything into the derivative formula. So we get f prime of a is equal to the limit as h approaches 0 of a plus h squared minus 8 times a plus h plus 9 minus a squared minus 8a plus 9. And everything all together divided by h. Right, if you of course use direct substitution, you will find out that it's not gonna work. You're going to have 0 over 0, which is the indeterminate form again. And so you have to make the simplifications. In this case, trying to get rid of the h in the denominator. So to do so, just going to expand the numerator and see what happened, okay? So you have a squared plus 2ah plus h squared minus 8a minus 8h plus 9 minus a squared plus 8a minus 9 divided by h. Okay, so a squared cancel out, plus 9, negative 9 cancel out, negative 8a and plus 8a cancel out, and you're left with 2ah plus h squared minus 8h over h. So now you can take h as the common factor on the numerator. You have limit as h approaches 0 of 2a plus h minus a divided by h. And the h cancel out. You're left with 2a plus h minus 8. And you let h approach 0, you get 2a minus 8. Sorry. So remember, this equation is used to find the slope of the tangent line or the instantaneous velocity, right? So that's bring me to the next question. For the next questions, I want to find or determine, right? This is the test a continuous problem from above. So determine the equations of the tangent line. To f of x at the point 3 comma negative 6, right? So you have the slope of the tangent line already, right? And you have a point here. You just need to find the equation of the tangent line, right? Given that a in this case equal to 3, right? So x is equal to 3, right? We have the slope of the tangent line is, so m equal to 2a minus 8, or 2 times 3 minus 8, or this is negative 2, right? So negative 2 is the slope of the tangent line. So the equation of the tangent line is So you have y minus y0 equal to m times x minus x0. Right, so y minus -6 equal to m is -2 times x minus 3. Right, so that's the equation of the tangent line. We simplify this further, you have -2x plus 6 minus 6. Oh, this is just -2x for the answer. Right, so therefore, y equal to -2x is the equation of the tangent line. To the curve y equal to, let me go back here, x squared minus 8x plus 9 at the point 3, -6. Let's look at another example. Find an equation of a tangent line. Uh, 2f of x equal to 3 over x at the point 3, 1. Right, so you have a point, you have a function. So it should be the same, right? It's the same procedure, it's just a different function. So first, in order to find the equation of a tangent line, you need the slope of the tangent line. Right? And the slope, it can be calculated using the formula we've been talking about. Right? So the slope of the tangent line to the curve f of x equal to 3 over x at the point 3, 1 is, so f prime of 3, right? This is the slope of the tangent line, is equal to the limit. Y is 3 though, because it's x value. So limit as h approaches 0 of f of a plus h, or f of 3 plus h, minus f of 3 divided by h. So that is the slope of the tangent line, right? So the job now is to substitute the function. So f of 3 plus h and f of 3 into the formula to calculate the slope of the tangent line. So the function is f of x equal to 3 over x. So f of 3 plus h is 3 over 3 plus h minus 3 over 3 divided by h. So I'm just going to write down 1 instead of 3 over 3. Right, so let's combine the numerator together. You have a limit as h approaches 0 of 3 minus 3 plus h divided by 3 plus h altogether, divided by h. I just want to remind you again that when you calculate the limits, try to keep the limit notations at all time. Until the last possible moment, right? Until the step of evaluating the limit, then you can drop the limit notations. Otherwise, you have to keep it at all time. You can simplify further. So I have the limit as h approaches 0 of 3 minus 3 minus h over 3 plus h altogether divided by h. So limits h approaches 0 of negative h divided by h times 3 plus h, because 3 negative 3 cancel out. And to the next step, you have h and h cancel out. You're left with limit as h approaches 0 of negative 1 over 3 plus h. When you let h approaches 0, you get negative 1/3. So that's the slope of the tangent line. So the equation of the tangent line is can start with this point slope form. Given m is equal to -1/3 and at the point you have 3, 1. So you have y minus 1 equal to -1/3 times x minus 3. Well, this is -1/3 x plus 1 again, or y equal to -1/3 x plus 2. Right, so that is the equation of a tangent line.